This little beast here is a Zener diode, and they're rather strange, but they can be extremely useful. What they do is they can vary their resistance to try and ensure we get the same voltage across them. This one on this board is rated at 3.3 volts, and that means it will be the maximum voltage we get across it. Now we always wire them up in series with a resistor, so that if we have a voltage higher than this target voltage, that excess is taken across the resistor. Let's have a look. If I move this to position A, it means we're using these 4 batteries for our supply, and that's reflected in this digital voltmeter here, which is showing 4.8 volts. I've taken out the other 2 digits because they bounce around and they just get very confusing. There's our voltmeter on the diagram, 4.8 volts across here. We come through the resistor and then we can see the voltage across the Zener diode by this meter here. And it's showing we've got 2.8 at the moment. We've got no current going through our load, but look, we've got quite a lot of current, 66 milliamps, going through the Zener, and it's needing to pull that amount of current to make sure we've got our target voltage across here. Now if I increase the supply voltage by adding a 5th battery, we're going up to 5.9 volts, you'll notice that the voltage across the Zener hasn't really changed a great deal. It's only changed by 0.1 of a volt. And if I go up to 6 cells, we're going up to a supply of 7 volts. And again, we've only gone up a fraction. So this is always trying to ensure that we've got the same voltage across it. Now at the moment, there's no load. But if I add a load in, that's not changing a great deal. It's keeping the voltage regardless of the load across here. The difference is that we've got 118 milliamps at this point of the circuit. We've got 78 milliamps going through here. We've now got 40 milliamps going through the Zener. So as the load changes, so the current through the Zener will change. So where do we use these? We use these where we need a fixed voltage in our circuit which is less than the supply voltage. They're very useful for small circuits, but they are wasteful. We've got an awful lot of current going through here, and that's why I've got a big resistor here, because it is actually getting very warm, pulling all that current through. Zener Diodes.